it's Linda with No Frills ASMR. So I ordered a few placemats for kids, I think, with different subject matters. And one of them is the periodic table. And I just did a video where I just traced all the, I don't even know what they're called. This is how much I know. All the elements. Because I had chemistry, I think, in 7th grade. I don't even think, maybe it was high school. Maybe it was freshman year. Maybe it was 8th grade. No, 9th grade. 9th grade's high school. Maybe it was 9th grade. But if I passed that class, it was because of extra credit or something. Because I just never learned it, and that's my fault. So I don't know what to do with this, to be honest, because it's so outside of my range of knowledge. So I thought maybe today I have an encyclopedia, and this is all like kind of, oh look, I'll show you, hold on, because this I bought, at the thrift store the other day. But this says family encyclopedia, so I assume it's kid friendly. And maybe it will be in language that I can understand a little bit. So I thought we could look up, I don't know, the periodic table, I guess, in here, and then just try to understand what it is we're looking at. And I know a lot of you totally understand this, but I'm telling you, I really don't, I don't know anything. I'm so clueless. I do remember memorizing that Fe is iron and Ag is silver. I feel like there were not anywhere near this many when I had to memorize it, but maybe there were. Oh yeah, that's helium, and Na is sodium. So I do know some of that. I remember memorizing that. But I definitely don't think I would have been in 9th grade. I don't know, what would that have been? 80, maybe 83? I'm sure they were here. I just don't remember. Anyway, okay. So I thought, let's look up, well, I guess let's look up the periodic table. I haven't used this yet. It's kind of nice. It has, all kinds of, it's got a panda bear. So I thought it would be just a fun reference. I do find, even though these books, like what is the date on this? Even though these books I buy secondhand, they're outdated, but 1997. But it's still kind of, I feel like I remember it more when I read it in a book than looking it up online. Oh, look. I kind of talked to somebody in a comment. They said they were inspired to try to learn things, which is so cool. And I just find if I do a quick Google and learn it, I'll forget it within an hour. I won't even remember I looked it up. But if I get a book out and look it up, I tend to process it slower and remember it more. I don't know if that's true or not. I feel like it. All right, what does this say? Periodic table. Arrangement of the chemical elements in order of their atomic numbers. Should we look up atomic number? I think so. I think I have to start at the beginning. Start at the very beginning. Atomic clock. Atomic mass energy. Atomic number. Atomic number, proton number. Number of protons in the nucleus of an atom of an element, which is equal to the number of electrons moving around the nucleus. It is abbreviated to AT, atomic, NO, number, and represented by the symbol Z. The atomic number determines the chemical properties of an element and its position in the periodic table. Isotopes of an element all have the same atomic number, but different atomic mass number. Okay, are we all understanding that? Let's see, what is the picture? The mass of an atom depends on the size of the nucleus. The nucleus of an atom makes up the very great majority of the atom's mass, as electrons weigh nothing. A uranium atom, for example, has the greatest mass of all naturally occurring atoms. It has 146 neutrons, 92 protons, and 92 electrons. What was that one? Uranium. So does that mean, because it's got, does that have something to do with the atomic number? Where's uranium? You are. Oh boy. Is it you are? Radon. Krypton. Oh. Oh boy. I apologize to anybody who understands chemistry. You're gonna, oh, here's uranium. So its atomic number is 92. Is it possible they found more, and because these look heavier, or is that its atomic number not the mass? Are they different? Because look, helium's up here with 2, but hydrogen has 1. I don't know if I understood all of the atomic number stuff. Okay, well, I don't know. I feel like we're closer. I could read all this. Atomic mass number, atomic mass unit. I don't know. I feel like I need somebody who understands to explain it, maybe. But a neutron, a proton, an electron. I'm just trying to remember the basics of all this. The electrons go around the outside, right? I do remember learning. It's coming back to me slowly. It's been a lot of years. Okay. Periodic table. Where were we? Let's just start over. Arrangement of the chemical elements in order of their atomic numbers in accordance with the periodic law first stated by the Russian chemist Dmitry Mendeleev, maybe, in 1869. In the modern form of the table, I'm so immature, I wanted to go. 69, dude. Okay, in the modern form of the table, the elements are arranged into 18 vertical columns and 7 horizontal periods. 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 vertical. Okay. True. Where were we? And 7 horizontal periods. What does that mean, periods? 1, 2, 3, 4, 5, 6, 7. And these 2 go here and here. Because see where it says rare earth metals 57 through 71? That's what these are. And this says actinide metals 89 through 103. So they're part of these rows, even though they're down here. I noticed that when I was tracing them. Okay. So that part's still accurate. The vertical columns containing groups are numbered 1 through 7, with a final column numbered 0. Okay. They don't show that on our big one here, but on here, and by the way, these are Roman numerals. I have a video on Roman numerals. I think I might redo it in case the sound wasn't good, because I like it. So they're saying you have these groups, And so this is group 1 here, and then group 2. It looks like all the way to boron. This is group 3. Going to where boron, and I think it goes all the way to here. This is group 3. And then group 4 is, well, that's confusing. Does it contain nitrogen? They put it right on the line. B and C, C and N. Unclear. Well, that's unclear. I need an expert for that. I'll look it up later. We'll revisit this maybe once I understand it. This is literally me trying to study, and you guys are looking over my shoulder. And then it looks like 5 is here, 6 is here. This is really confusing. And 7, why are they like at the lines? I'm gonna have to, and then 0 is here. So they're grouped like that. But that's, I don't know. And what is the point of that? I don't know. Because they're already numbered. Okay. So we have not, I don't understand that fully, but okay. We know it's a thing. I just don't know why it's a thing. Or exactly which ones go where. But that's for later learning. Okay, the vertical columns containing groups are numbered 1 through 7 with a final column numbered 0. The metallic transition elements are arranged in the middle of the table between groups 2 and 3. So these, what do they call those? The transition elements. See, in yellow, it says transition metals. So that's what all these yellow are. So that's kind of nice. This one has it mapped out for us. Alkali metals are group 1 right here. Okay, and alkaline earth metals are group 2. See, they have alkali metals and alkali earth metals, but they do show this one being a non-metal, but it seems to be in group 1. So I don't know what the deal is with that. That's hydrogen. All right. Metalloids and nonmetals are found from group 3 through 7. Okay. And noble gas, which are inert gases, are collected into group 0. So these are group 0. So this is really here. I guess so. The way they show it on here isn't super great, I think. The elements in each group have the same number of valence electrons and accordingly have similar chemical properties. Okay, valence electrons. I don't know what a valence electron is, but basically they're saying anything that's within a group has a similar chemical property. Okay. Elements in the same horizontal period have the same number of electron shells. Okay. So if they're going this direction, they have the same number of electron shells. Huh. I guess I understand that, I guess. Okay, and then this, each one of these, it's hard to see, I have to say. My pet peeve with this is they put the dark print. Why didn't they make the print white if you're using a dark color, ink? Because it's super hard to read. Like, it's not just my eyes, it's hard to read. It's easier to see on camera, honestly. But, so we'll use a white one. So this number here, the 21, actually, hold on, let me grab if I can get one. So up here in this corner, you have what's called the atomic number. And then we'll do hydrogen. And then the H is the symbol. And then underneath they write hydrogen. So that's the name. And on this little thing they put how it can be used and where it can be found in nature, which is kind of nice. So they show hydrogen is in the sun and stars. And they show like, let's just pick something. Molybdenum is in X-ray technology. Gold is in banking and finance. Cadmium is in paint. So that's kind of fun. But I think on a regular periodic table, it'll just have the atomic number, they have the atomic weight. They don't have that on here. So the atomic weight of hydrogen is 1.0079. Okay. So, atomic number. Symbol. Do they call it an atomic symbol? Yeah, they do. Atomic symbol. The name. I guess that's atomic. Nope, just name of element. Name of element. And then the atomic weight. I never know how to spell weight for some reason. Atomic weight. Okay. So on here they don't show that. Should we look up what the atomic weight tells us? I'm sure by we I mean I won't really understand it, but we'll try. Okay. Here it is. Atomic mass number, atomic mass unit, atomic number. Atomic number. Number of protons in the nucleus of an atom of an element. So the atomic number, the number of protons in the nucleus, which is equal to the number of electrons moving around the nucleus. Okay. It is abbreviated. Okay, we already read that. Atomic mass number. Number of nucleons, protons and neutrons, in the nucleus of an atom. Well, what do you guys think? Are we in full understanding of this now? What can I do with this chart? Like these are like potassium, fruit and vegetables, calcium, seashells. Magnesium is in chlorophyll. Beryllium is in emeralds. Oh my, that's beautiful. Barium in glass making. Radium, cancer treatment. Yeah, so they're broken up into alkali metals, alkaline earth metal, transition metal, basic metal, semi-metal, non-metal, halogen, noble gas, lanthanide, and acetonide. I don't know what acetonide means. Or lanthanide. Boron fertilizer. I think that's what borax is made out of. I use that in my tin plated food cans. Some of these don't say what they're for. That's funny. Like all these, they don't. Well, this says synthetic radioactive elements used in atomic research. Oh, look at this one. Holmium is laser surgery. Well, I don't know that I'm more educated than I was before. If you guys have any ideas of what I could do with this, I don't know. I feel like chemistry goes beyond. Let me put it this way. I'm kind of curious about things in general, and if I found something to be really curious about, I think I could find a way into this. But just looking at this, and it's too, not a real thing. You know what I mean? It's too much. I don't know what the word I'm looking for is. Thinking. Too much thinking. I don't know. I'll have to think about how to venture into the periodic table. Let's see if there's anything about it in my book of cultural literacy here. I don't know if there will be. I don't remember how much science is in here, to be honest. It's loud crinkles today. Periodic table of the elements 482. Periodic table of the elements, a chart of chemical elements that displays them in rows horizontally in order of increasing atomic number, and vertically according to similarity of the structure of their atoms. I feel like that's more clear for some reason than the other one. So this way, they're going by horizontally in order of an increasing atomic number, right? So this is 3, 11, 19, 37, 55, 87, okay? And vertically according to similarity of structure of their atoms. So this sodium and say neon, let's say lithium and neon are like the least similar in structure. Would that be correct? They're saying they're less similar, but I guess they're still in groups together. So it could be that one's. It could depend on the group. All right. According to the structure of their atoms. The position of an element on the table thus gives useful information about the chemical properties of the element. Okay. And then they have the table here. And they say to go look up Dmitry Mendeleev. I think they spell his name differently than that book. All right, let's take a look. A, B, C, D, E, F, G, H, I, M, M, E. I know you guys, usually I know something about it, or I do a little studying. This one I'm coming into looking at it for the very first time with you, so don't also don't think I'm stupid. I'm not. I just don't know chemistry. Why am I having trouble remembering this? 4, 7, 8. Okay. 4, 7, 8. Ba-ba-da-bum. Here he is. Dmitry Mendeleev. A Russian chemist of the 19th century, Mendeleev first wrote down the periodic table of the elements. That's all you got? It's open for more. Okay, well, so we learned a couple of things. We learned Dmitry Mendeleev was the first one to write this down in 1889. We learned that they go by atomic number, getting bigger, going this direction, and they go their their electrons are more different the further apart they are. I think that was it. And they're grouped for some reason. And that at the top is the atomic number, the symbol, and the name. And then on a chart that isn't for kids, you'd have the atomic atomic weight at the bottom. All right, well, we learned something. And that these two rows actually go here. Because when I first got this, I was like, did they add these rows? Because I didn't really remember that, if I'm honest. Anyway, all right, guys. Well, I know that wasn't my brightest work ever, but hey, we learned together. All right, I'll